All right, thank you very much. This is the last talk. My God, the drinks are like nearly around the corner. We're nearly there. So who is excited to hear about generative AI at 4:50 on a Tuesday? Wow, there's like 3 hands. It's amazing. Well, you 3 people are in for a treat. What can I say? The rest of you, well, good luck. So my name is Sbarski. It's funny that I had to look at the notes. And I will talk to you about my most recent project called Matchbooks, like it says on the screen behind me. So Matchbooks is an iOS app that you can install on your iPad or iPhone that lets children create books in a very kind of like interactive, safe, fun, exciting manner. And of course, it is entirely serverless, so I'll tell you how we built it. But first, a little bit about me. So this is me. I'm an AWS serverless hero, which means that I do talk about AWS and serverless too much. Yes, I wrote a couple of books some years ago. One of them was translated, the first edition was translated to Chinese and Japanese. And my friend Alicia, who speaks Japanese, tells me that that translation was fantastic. But, you know, I believe her. I helped to co-organize the serverless meetup in Melbourne with young Matt, who just did a presentation. There he is. So please, if you are in Melbourne, please pop in, give a talk, participate, enjoy the pizza. It's wonderful. Like Lars said, I used to work for a little company called A Cloud Guru. I was VP of Content and VP of Education and Research, and it was bought out by Pluralsight. I left. And then I started this little incubator lab called Hot Hands. So look, the idea is that behind this incubator is that we want to use AI to create exciting new user experiences. AI is not the point for us. It's not the aim. Like, we're not going to be building, you know, new foundational models or anything like that. We think that we can create beautiful, well, all of us can create beautiful, interesting new products using AI, using cloud computing, using automation, using machine learning. It's all possible. And we can create something special that hasn't been possible before. And kind of that's the aim of our incubator. Oh, there's our little logo. But first, let me just show you Matchbooks. Let me show you what it does. This is our first project. So when you begin the app, you get to meet 2 AI-driven narrators. You get to meet a koala named Kai and a hedgehog named Liv. So yeah, when a child begins using the app, this is what it looks like.
Hey, hi, I'm Kai. Welcome to Matchbooks. Now, don't look surprised. Yes.
Can you hear that or not?
That's right. That's totally normal.
Sorry? No. Well, it's gone from like, oh, hang on. I know how to fix this. Wait a second. There we go. All right, take 2. We can do some editing, right? Back in the recording. It's going to be great.
Hi there.
Hey.
Hi, I'm Kai. Welcome to Matchbooks. Now, don't look surprised. Yes, I'm a talking koala. That's right. That's totally normal. That's not weird at all.
Not at all. I mean, I'm a talking hedgehog, and I come from a long line of talking hedgehogs. My mom was a talking hedgehog. My granddad was a talking hedgehog. Okay, my uncle doesn't talk that much, but he's just grumpy.
Right. Well, welcome to the magical woods. This place is very special, and we come here a lot. In this place, you can bring storybooks to life just from your imagination. How cool is that?
Yeah. We can create stories about magical creatures or amazing heroes, even your favorite toys or pets. Or, if you're like Kai, you can make story after story after story about Kai Koala, the king of the world. Seriously.
Hey, I told you not to tell anyone about those. Plus, Kai Koala, king of the world, has a great ring to it.
Anyway, let's get started. Who would you like to help you build your stories? Tap on one of us and then hit the button to start creating.
This is amazing when you have like 30 minutes to talk and you don't have to say anything. You can just stand and, you know, listen. So anyway, so you get to choose your narrator, Kai or Liv. And after you go through the introduction and create your profile, you can create your first story. And the story is created by really kind of describing the plot points. You just say, hey, this is what I want to happen in the story. And if the AI system needs more information, it will basically prompt you to give more additional details, like tell us about the characters or tell us what's happening. Responses from the narrators, from Liv and Kai, are controlled entirely by AI, right? This is all generative AI. And they are not pre-prepared by us. So here is what it looks like.
Hey, it's time to build a story. To start, can you tell me who this story is about? You, one of your toys, maybe your pet, or a completely new character made just for this story?
This story is about the wonderful audience at SLSDays.
You're all welcome.
Thanks. I need to mull that over. That's a unique idea, Papa John. What happens to the audience? Is there a challenge they need to overcome, or a mystery they solve together?
The audience comes together to learn about serverless tech and generative AI.
Gotcha. Just a moment, please.
Well, anyway, riveting stuff. As you can see, the story is going to be absolutely amazing, I'm sure of it. It takes a few minutes for our story engine to create the first 6 pages. And while you're waiting, you can play a little game. I will not spoil the game for you, so please download the app, try it out, tell me what you think. But after the story is created, you get a little read book button that you can hit, and you can read the story. Now, again, everything is controlled by a large language model, including the story, all the images. The voiceover is also AI generated. And here's what it looks like.
In the hushed town of Circuitville, nestled between whispering woods and twinkling streams, a curious building stood out. It was known as the Learning Hub, its roof shaped like a giant laptop lid, and inside, a grand secret awaited those who dared to explore. The walls of the Learning Hub were lined with shimmering screens, each displaying swirling galaxies of information. On one special day, the wonderful audience of SLSDays converged here, their eyes wide with wonder, about to embark on a journey into the world of serverless technology.
Anyway, I'm not going to actually just read the whole story to you now. You can create one yourself. This isn't what the talk is about. But finally, there is a large library that you can kind of go through. You can see a whole bunch of stories that we've created ourselves. You can make your ones, of course. And there are interpretations of classic stories as well, built kind of with the new AI imagery and voiceovers. So there's, I think, a lot of fun to be had. Some interesting points that I want to kind of point out that you couldn't get from this really brief demo. So first of all, you create a profile when you begin the app. So you specify your name, your age, and optionally, you don't have to, but you can also specify your gender. Now, this information is used by the LLM. So if you reference yourself and ask for yourself to be included in the story, it will actually include you in the story. And before, you might have heard that it referenced me as Papa John. That was just accidental. I created a profile called Papa John. Whoops. Our story engine creates 6 pages at a time. And after 6 pages, we ask the user as to how the story should be continued next. And you can really say or type in anything you want. So you can take stories into crazy, uncharted new territory. You can do really whatever you want, within limits, of course. The LLM will adapt to what you say. So I mentioned that generative AI is used to generate narrator speech. So when you talk to a narrator like Kai or Liv, Gen AI is used to generate all the output, but also the gestures, also the way they blink, the way the head tilts, the way they gesture to you, if they jump up and down, that is all controlled by a large language model. Nothing there was pre-baked. As with any other system, we support multiple accounts, profiles, subscriptions. You can share stories, there's family sharing, and this is all serverless, and I will show you the architecture in a little bit, or some of the architecture. You can create stories like you saw, or view stories created by us. Now, this is very important, and I've been honestly nervous about this from the very start. Safety and privacy is very important, right? This app is for children, so we need to be very, very, very certain that what we produce is safe for children to consume. So I'll give you some examples as to how we have addressed this. So first of all, on device, when you say something, your voice is converted from speech to text straight on the device. We don't actually send a recording of your voice to AWS or anywhere else, right? So as soon as we convert on device speech to text, we delete your voice recording. So that is never, ever, ever stored. So that's one. Then we check whatever input we get from the user against a set of block lists. We check for, obviously, swearing, adult themes, etc. So that's the first level. Then we have a number of workflows. We have a number of firewalls in our workflows on the backend that actually check all prompting, everything said by the user against a set of filters, right? We firewall against bad input. And finally, we have some things baked into our large language models to deny bad input from users. Obviously, we err on the side of safety all the time, and that's very important because, one bad situation, somebody posts something on Twitter, and that's it, right? No parent would trust this app ever again. So it's important for us too. So how we build this? I mean, there's just the three of us, right? There's myself, Sam, and our wonderful UX designer, Tate. And we needed to be as fast as possible, and we wanted to be able to iterate on user feedback immediately. So here's our decision-making process. Here's what we decided. We went with serverless first, right? We wanted to build the system as quickly as possible. We wanted to have the infrastructure up and running, to have flexibility, and to focus more on the generative AI and the user experience, rather than thinking about infrastructure or deploying servers. To that effect, we've leveraged as many AWS and third-party services as we possibly could, and that allowed us to obviously focus on the unique aspects of our product. Having a magical user experience, like talking to a koala that actually responds to you, was a key factor as well. We wanted something that could easily be used by a child. And we actually have two modalities in the application. You interact with it using voice. That's kind of the primary modality. But you can also type as well. And that works well if you are in a quiet environment. Maybe you are in a car, and if the child is together with the parent, they can type in instead of speaking. We wanted to make the development experience quick and easy. Again, there's just the three of us, so it needed to be fast. And this is an interesting one because this is a very fast-moving space. We use cloud computing and serverless, and that moves quickly, more or less. But generative AI is absolutely crazy. It is changing all the time. And I'll tell you about some of our strategies about dealing with generative AI and how quickly it evolved and what we did, how we thought about it further in the talk. So this is what we decided for the backend. So we use serverless stack framework, and thank you to young Matt for giving a beautiful introduction to it just before. Like Matt said, it is basically an abstraction on top of CDK that allows for easier development of serverless applications. We use Lambda for compute. We use a lot of step functions for orchestration of various workflows that happen. DynamoDB is our primary database. Of course, we don't do single table design. If Alex Debris is watching this in recording, I'm very sorry, and I apologize again. We use API Gateway. We both use sockets and REST, interestingly, and I'll mention why later. And of course, we use the one service that will be with us until the end of the universe, S3, or at least until the end of the internet. So those are the services. For the front end, we use Svelte, or I guess SvelteKit. It's basically a front-end JavaScript, TypeScript framework that allows you to create single-page applications. It has a whole number of excellent features, like server-side rendering and so forth. We use a bunch of different libraries, including Free.js for animation of 3D characters. Our app is an iOS app, right? So we use Capacitor.js to actually wrap our Svelte application and create a distributable build that we can then distribute via the App Store. And we also use Netlify for a few things. When you create a story, you can share that story. You get a link, and then you can send it to someone. And then anybody with a browser can actually watch the story. So they don't need to actually install the app if they just want to watch or hear the story. In terms of generative AI, so We currently use GPT-4 and 3.5 Turbo for stories and interaction. And our engine actually switches between 4 and 3.5 Turbo depending on the interaction or desired output. So for basic interactions, when you're just talking, 3.5 Turbo is used. For story creation, we use GPT-4 because it is much more creative and interesting than 3.5. And the reason why we actually use both is issue of price. 3.5 is a lot cheaper than 4 for now, so we kind of switch between one and the other to save on price, but still get really good output. If there is an outage, we actually have failover to Claude on Bedrock, so that'll work. For images, we use DALL-E 3, same thing. And if there's a failure with OpenAI, something happens, and when I get those outage emails, every other day, I get a little nervous. But we can also fail over to Stable Diffusion XL on Bedrock. And finally, we use 11 Labs for human-like voice generation. So we've tried a whole bunch of different things, right? I'm not an AI engineer. I had to learn all of this from scratch. So did everybody else. And we tried making our own models and running them ourselves. And we used a service initially called RunPod, and I know young Nick knows a lot about that service over there, so if you have questions, talk to him. RunPod is great, right? So you get a model, you can deploy it into a container, and it runs. And is there anybody from AWS here? Good, OK. So honestly, it is way better than alternative services from AWS. It's better than ECS. It's better than Fargate. It's just much easier to use. It gives you a GPU immediately. Sorry, but Fargate still doesn't support GPUs natively, right? I looked last week, and it's still an open issue from 2019. Matt knows that it's issue number 88. If you want to actually have GPUs in Fargate, you have to go ask permission from AWS to provision P-class instances. Then you have to create all the containers yourself and just manage them. And it's just a lot of overhead. I know that Bedrock now allows you to bring your own custom models and run those. But my understanding, and I could be completely wrong, so please double check this, but my understanding is if you bring your own custom model to Bedrock, you must sign up and pay for provisioned throughput, which is really designed for kind of large inference workloads. So it's not really serverless, right? It's not pay-as-you-go. And that's kind of what we really needed. We tried a whole number of different voice providers. We initially used something called PlayHT, which is a great SaaS. Over time, we switched to 11 Labs because we found that the quality and performance was a little better. We, of course, tried all the major cloud providers, AWS, Azure, GCP. I'll be honest, voices are terrible by comparison. So yeah, not great. We played with a number of stable diffusion models, countless variations. There is a lot of activity happening in this space. It's evolving literally every day. So it's changing. Once you start looking into it, it is actually crazy. We tried Meta's Llama, which was all right, pretty easy to use, easy to get going, and Claude via Bedrock. We actually tried Claude in Bedrock while it was still in preview, and it wasn't as good as GPT-4, which is why we kind of settled on GPT-4. But Claude 3 is excellent. So if I was kind of evaluating again, maybe Claude 3, which is the current version in Bedrock, would be the winner. So we learned a lot of lessons the hard way, and I'll share just a few stories. I think I still have time. You're going to hear some battle stories. I may cry a little, break down, suffer some PTSD, so buy me a drink. I mean, the drinks are free, right? Excellent. So when we first started building Matchbooks, we looked for a framework to deal with the large language models we were going to use, right? We needed something because we were building complex user interactions between the user and the AI. And the first framework that I kind of got interested in was called Microsoft Guidance. Is anybody familiar? Has anybody heard of that framework? No, excellent. So it was basically a framework built by Microsoft to use OpenAI, to use ChatGPT, and manage it effectively. So we built a whole bunch of Lambdas in Python, started using Microsoft guidance, and then all work on that framework stopped for like 6 months. Nothing was done. There were 300 issues outstanding on GitHub. Nothing was being done. So that was a little sad. There were critical bugs, and we kind of had to make a change, right? We couldn't continue using something that wasn't really supported, even though I thought Microsoft would support that framework. This was their baby. So then we switched to LangChain, which is, I guess, the most popular open source framework for managing large language models. And we implemented everything with LangChain. But I'll be honest with you. I just find LangChain to be difficult. I don't know about all of you. Maybe, I mean, I'm probably just an idiot, but I just find it hard. Like, it's poorly documented, I think. So these days, I'm finding that I'm just making calls, like SDK calls to OpenAI or Bedrock myself, and I'm saving state or prompts in Dynamo, and I'm kind of, it works. It's fast, and I'm not struggling with all the complexities. And this could be because LangChain is still, it's still early on, right? It's still very early days, and of course it will improve, and documentation will get better, but for now, I find it kind of complex. We tried different voice providers, as I mentioned on the previous slide. And one thing that I continue kind of relearning in my career is that software engineering is always a game of trade-offs, right? Sometimes I would find like a new voice provider, and it would be fantastic, but it would be slow. Or there would be one which would be near real-time, but it would have a terrible performance in terms of quality or latency or something else. Things are getting better every day, but if you're looking for a good voice provider, it will take a little bit of time for you to choose something that you really like. There are pros and cons with every service that you will use. We ran a number of models ourselves, like I mentioned, like Llama, like Stable Diffusion XL. It's interesting, but in the end, for performance, quality, price, availability for our use case, we just thought, okay, we'll use OpenAI, we'll just do API calls, we'll use Bedrock, we'll do API calls to AWS, and that's good enough for us. But of course, we are continuously evaluating models and seeing where they are. Who knows where we'll be in 6 months. We make stories, right? And we want the large language model to be very creative, to be really fun. And so we considered, how do we kind of tune or improve the large language models that we use? And we considered fine-tuning versus providing a lot of context in the prompt up front, right? So in the prompt, you can just kind of give a lot of information up front. You can say, hey, here are examples of things that I consider to be important. When you create some output, look at these particular examples, and then give me something good. So in the end, we went with that approach. We provide a lot of kind of context to the LLM rather than fine-tune it. Again, we are re-evaluating all the time, so maybe fine-tuning for us at least will be a better approach, in the coming months. LLMs are changing quickly, right? It's insane. When we began building Matchbooks, we had trouble representing characters the same way. So if you had a character called Bob, Bob wouldn't stay the same in images from page to page. And so we're like, oh, this isn't good. This is going to confuse our users really quickly. And so we thought, okay, do we go and try to fix that ourselves? Or do we just assume that there are people working on it? And we made an assumption that this problem would be fixed. And to a large extent, it has been fixed. So now the consistency of images is way, way better than it was 6 months ago or 12 months ago. So it was kind of like a lucky guess. We didn't make a decision to spend time fixing that issue ourselves, but we left it to people who are way smarter than us to address that challenge. Same with JSON output. Like ChatGPT or GPT 3.5 struggled outputting JSON. It was a big issue. Now it seems to be next to perfect. We haven't had, I'd say, an issue with broken JSON in about 6 months. And finally, LLMs can be unpredictable. They can give you different non-deterministic output even when you give it the same input. It will hallucinate all kinds of things. For us, though, that's not a bad thing, right? We are creating stories. So for us, crazy hallucinations and crazy things are not actually bad. Like, we want stories about crazy pumpkins going into a fight with, noble cucumbers or something like that. So for us, it's a good thing. For other use cases, maybe not so much. I'm not expecting you to kind of see exactly what this is and all the various Lambda functions, but this is an example of one of our workflows. So this is a step functions workflow for creating new stories. We have a number of workflows and step functions. We have another one, for example, that generates new stories each week for our users. A few notable, I guess, things about this workflow. We use a number of states like parallel and choice to help with the orchestration. We use a lot of inbuilt state management as well, so we don't need to do it ourselves. We basically have a lightweight ETL kind of built into the step functions workflow. So we change state as data flows from one part to another part. I know the diagram is very hard to see, so I'll just give you an overview of the major blocks. So at the very start, when the workflow kicks off, we get all the user input. We make sure that there's nothing dodgy in that user input. We hydrate or we load the existing user profile. And if we are continuing an existing story, we load that as well. Then we pass all of that data to the next step. In the next step, we validate safety. So we run a number of checks again on the prompt. We can sometimes substitute the prompt. We can say, hey, this prompt isn't good enough. Let's do something else. Or maybe we fail the process entirely. We say that, look, this story is not appropriate for children. We will not actually even continue. But if we got a thumbs up, we generate the initial 6 pages. Then the next step, a separate step, we generate character descriptions. So we generate what new characters look like if they have been mentioned in the previous 6 pages. And we need to save these descriptions separately. So later on, if we need to kind of render these characters again, we can load these descriptions from a database and know exactly how to draw these characters. Then we start generating the 6 pages, the voices. Sorry, we generate the images for the pages and the voices. And this is parallelized, right? It happens at the same time 6 times. We obviously have some safety built in, so we check all the prompts here as well. I mentioned before that after 6 pages, the user gets a question, so they are asked, how should the story continue next? And they're given some alternatives. So this is where it happens in the workflow. And if we are creating a story for the first time, we will create a story summary and a cover image. And this is kind of optional and conditional, and only happens at the very start. Finally, we update the database. If there was any issue in the workflow, if anything failed because of an outage, for example, with OpenAI or Bedrock, or if there was a safety failure, we do a little bit of cleanup. And finally, we send back the response to our application, right? And that could be either the 6 pages that we created, or it could be an error message saying that, sorry, we couldn't continue your story, we couldn't build the story because something happened. And this is, by the way, done via WebSockets. One interesting thing that we had to build, implement, was an LLM load balancer. So with OpenAI, you can open an account, but you have a limit on the number of API requests that you can do, right? They actually have 5 tiers, but even at the 5th tier, once you've spent a lot of money, you're still limited, right? And that makes sense. But what is totally fine is to open multiple accounts. I mean, look, I've read the TOC. It doesn't say that you cannot do that. So anyway, we pay for all these accounts. There are no freebies. So OpenAI, if you're watching this, we're good, right? Anyway, we built an LLM load balancer that will route requests to accounts which are least saturated by API requests at any given moment. So we store the number of requests, the time, which accounts are being used in Dynamo, and we kind of update that as the situation changes. And if we suddenly have a huge spike in the number of requests, we can be sure that we can satisfy them all. That is unless, of course, we have thousands and thousands of new users suddenly coming onto the platform, then maybe there could be some, could be problem, but I think we'll be okay. In the 4 minutes I have left, this is like my second last slide, so we're getting through this. I often like to mention a talk by Tim Bray at reInvent a few years ago. So Tim defined a few high-level rules for modern applications. This is what he said. He said, think about security and compliance first. Use microservices. Go serverless where possible. Obviously have a robust continuous deployment, continuous integration platform. Monitor, monitor, monitor. That's the link to the talk, so you can watch it yourself. And look, those are all good calls, and I agree with all of them. But here is my take. And again, this is my personal opinion. So first of all, on the issue of microservices, I don't actually think that microservices are appropriate in all situations. Ooh, controversial, last talk of the day. But hey, I'm going to die on that hill. I think the answer is that it depends. Right? For applications at scale with multiple teams, multiple bounded contexts, yes, a microservices approach is probably the right approach. But if you're working on a smaller project with a narrow bounded scope, if you're a startup, right, wanting to get to market quickly, then maybe a serverless monolith is not a bad idea, right? And we kind of have a serverless monolith, right? But it's OK. It got us to market. It's clean. It's easy to kind of work on and extend. And in the future, if we do have multiple product teams and we need to scale it, I'm sure that we would be able to decompose it into microservices if that is what's truly needed. Automation is a must. I don't think that that is controversial. Serverless systems are distributed systems. If you're dealing with AWS, you are dealing with a lot of other services apart from Lambda. You might be dealing with non-AWS services too. You will have hundreds of interconnected, complex moving parts. And if you do not automate deployments, upgrades, monitoring, the complexity of the system will crush you no matter what. So you need to automate everything from the very start. And I'm very strong about that. And for our system, which isn't even huge, we'd be lost without a framework like serverless stack. I should actually mention that we use GitHub Actions for deployment. I learned this lesson in my career all the time, over and over and over. But it feels especially true in the world of cloud computing and generative AI. Look, simply, please don't optimize too soon. Keep things just a little bit loose. We tried that. That was our approach. And I'm thankful for it, because we were able to evolve and change fairly easily. Generative AI is outstanding at some tasks, right? But we know that we cannot trust it 100%. It will hallucinate things. But for fiction, for creating ideas, for user conversations, it's great. And look, we know that this is only version 0.1. We're really at the very start of this crazy new wave. So it's actually even hard to predict what will happen in 6 to 12 months. Things will get better. Things will get more precise, faster. Cost is a thing with cloud computing and, of course, with generative AI. For now, we're glad to be using Lambda. Our costs are very low. We're only paying when the user is doing something useful. We're not paying for idle, which is important for us. And same for generative AI, right? We could be running our own models, paying for them, paying for containers, just always sitting there. And maybe one day that's what we'll have to do. But for us, we're calling out to various APIs, and it suits our overall serverless ethos. It works for us. And we can switch between different models to optimize cost as well. Finally, we know that anything can and will probably fail. Yes, Lambdas will fail, and so will OpenAI. So when you make a request, make sure that you can handle the failure mode, right? Sometimes if you make a request to a large language model, you'll get gibberish, right? You'll get crazy stuff. Or maybe you won't get anything at all. So just make sure you can trust but verify and handle failure if it actually happens. And with that, I've gone 1 minute over, but I do want to thank you for listening to me, for being at this conference. It has been amazing. I think I'm obligated to share an image of my book, but I think you should actually just go and buy Sheen's book, because it is amazing. So please, please check out Sheen's book. It's really good. But with that, thank you very much, and over to you, Lars.
Thank you, Pete.